Okay, today we're going to talk about energy transfer. And energy is transferred, heat energy generally, three ways: conduction, convection, and radiation. In conduction, the molecules actually touch each other. So here is kind of an example right here. So we have our pot. All right. So if we put the pot on our burner, here's what happens. The energy from the burner goes to the pot. Now, depending on how you have your burner set up, let's say it's an electric burner. Okay, so the electric burner has a burner, so it's got a coil, okay? And that coil is made out of molecules. And those molecules, each one of those little tiny molecules, is vibrating. So this little molecule here and this little molecule here, they're vibrating back and forth, and they're vibrating back and forth, and they're vibrating back and forth, and they're getting all hot and everything, because that's really what hot is a bunch of vibrations. Then it comes and it touches our pot. Well, this molecule here that's bouncing around all over the place, okay, is going to touch the bottom of our pot. Okay, because like here's the bottom of our pot, and here's a little molecule on the bottom of our pot. So this guy here is vibrating back and forth, and he's going to crash into this guy, and he's going to cause this guy to bounce back and forth, and that's going to cause the next guy to bounce back and forth, and the next little molecule to bounce back and forth. And do you see how they're bumping into each other, and they're causing each other to vibrate back and forth, and they're basically transferring that energy by bouncing back and forth and bouncing off of each other. In conduction, there is some sort of contact between two different materials and atoms within a material. Let's say we have let's say we put a spoon into our pot. Let's put a spoon into our pot. So our pot's getting all hot. Okay, that's a lovely spoon, isn't it? Our pot's getting all hot, and it's transferring the energy to the spoon. And then that's transferring the energy to the next part of the spoon, next part of the spoon, next part of the spoon, next part of the spoon. Keep going up and up and up and up until now I'm trying to grab that spoon with my little hand, and I'm going, ouch, that's hot, because it's a metal spoon. But what do we generally put on metal spoons so that we can touch them? Generally, we put plastic on them. So what makes a good conductor? Good conductors are materials that have atoms that can move freely, atoms or molecules that can move freely. They can vibrate easily. Okay, and this happens best in metals. Metals are our best conductors. And part of the reason why is you have all these little individual atoms, and all those little individual atoms are sharing electrons throughout each other. And so it's actually the electrons that are free to move. The atoms can bounce back and forth, and they have a nice regular pattern, so they can bounce back and forth, plus the electrons can move back and forth, and that makes them good conductors. Now, things like plastics, not a conductor. Plastic is not a conductor. Okay, plastic has this atom attached to this atom, attached to this atom. They are firmly attached in a way, so there's an arrangement of the firm attachment, and so they kind of have to stay where they are. So plastic, non-metals, gases. Gases are horrible, horrible conductors, because gases, I've got this gas molecule, and then way over here I've got another gas molecule. So this guy's got to go like forever before he can even find somebody to collide with to transfer his energy. So gases are the worst conductors. And a vacuum is an area where we have actually no molecules. Guess what? Not a good conductor. And notice when you have a insulated cup, a lot of times there's like a double cup. You know, if you go and buy those fancy coffee cups with the little sippy thing in them, there's two cups with this empty space in between, the two cups. And that's basically empty. There's nothing in there. So there's nothing to allow the conduction of heat. So if you've got this hot beverage in here, that heat can't really get from here into the atmosphere. It can't get there because it's got to go through this space here in the middle where it has to go in this space here in the middle where there's like no molecules to transfer that energy. And so it doesn't really get out very well. That's why these are good insulators. So good conductors are metals. Metals are our best conductors. Actually, it turns out that diamond is the best conductor, which is really interesting because it does have that regular structure that we were talking about with the nonmetals, but it is actually a very good conductor, which is interesting. Nonmetals, plastic, glass, these are all poor conductors, and a poor conductor is an insulator. Okay, so all of these guys here are insulators. Glass and a vacuum. So if you're looking for a good conductor, you want a metal. Okay, the second way that heat is transferred is convection. We've heard of convection currents, most of us. Convection currents occur, we have our pan here in the water, and we're heating it up, and so the bottom of the water is getting heated up. But when the bottom of the water gets heated up, it gets to be less dense. And we know that things that are less dense tend to rise. So it's going to rise. That hot water is going to rise. But then when it gets to the top, it's coming in contact with this cooler water, and so it's going to cool off. And so when it cools off, it gets less dense. What happens to less dense materials? They sink. Okay? And then that colder water is now getting heated by the coil down here, and it goes through that process again, heats up, it rises, cools, and it's able to transfer the energy. If you've ever watched water boil, okay, you'll see that the water in the pot generally rises on the outside. So it rises on the outsides and then it sinks on the inside. And so if you go and watch boiled water, you'll see rising and falling of the water. And it's transferring its energy until the energy is all equal and it all gets to be boiling water. If we try to heat our pot from on top instead of on the bottom, the top layer gets hot, okay? The hot water at the bottom or the hot water at the top is less dense, remember? Is it going to sink? No. Less dense things rise. And so that hot water is going to stay at the top. Is there going to be a distribution of heat throughout the material, throughout our pot of water, the whole pot of water here? You would think yes. because these molecules can hit those, these molecules here at the top can hit the next molecules, can hit the next molecules, can hit the next molecules. But remember what materials were good conductors? Remember they were metals. Is water a metal? No, water is not a metal. Water is an insulator. It is not a metal. And so it doesn't transfer that heat down to the bottom. This is the reason why your pool, the top, a couple inches in the summer can be warm, but then you dive down, the bottom of it's cold until everybody starts splashing around. And then the splashing around mixes up all the water and makes it more even. And the last form of heat transfer is radiation. And it's transfer energy by electromagnetic waves. It's through space. It's through the air. And it's just, you know how you can, like, you see the hot asphalt and you can see kind of the heat radiating off of it? That's radiation. And well, it's actually something else, but we'll get to that later when we start talking about diffraction. Not diffraction, refraction. But there are waves coming off of this. You don't have to actually touch the pan with your hand to know that it's hot. You can put your hand just here nearby and you know it's hot because you feel the heat coming off of it. It's radiating. The heat is radiating off the pan. Similarly, that's how the earth heats up. The sun, our friend without whom we could not survive, is giving off all these light rays, different types of light rays that are striking the earth and warming it up. It's transferring that very much heat that it has to the earth via electromagnetic waves. And that's the different ways that heat is transferred from one place to another.